All right, real quick, quick reminder, tomorrow we have book checks. So if you have your book, have a book cover on it. We're doing book checks tomorrow. If you have multiple copies at home, bring those both so I can check the numbers. I know some of you might have them. Homework that we've previously had, if I handed it out to you, you can make fixes, turn it back in. Eric, here you go. Here's all your homework that you missed yesterday since you left. That was the stuff that we got back. So if you want to retake, you can always retake tests. You just have to come in the morning or after school and stuff. All right, we're just going to take a few notes today. I think this is pretty straightforward. I want to do a quick review of some geometry facts. I'll have you do a few problems where you have to actually draw some stuff for me. So you have to draw some stuff for me. So it's going to be good because when we get into geometry sections, you have to do drawings. So we'll eventually do some different sketches here. There's Connor. Right there. Yeah, it's my testing setup for all my other classes. That's how I took the test for them.
We're testing today?
No, that was my other classes. So, all right, we're gonna take a few notes, and then I'll have you kind of work on a couple things for me. So the section we're in, we're starting chapter 7, 7.1 today, which is intro to basic geometry. The goal today is to take a few notes, do some more hands-on drawing today, and then we'll have you do a couple of rounds where I want you to draw some stuff for me. Okay? The big thing here is we have to do a quick review of some of the vocab words we discussed yesterday, and we have new vocab words today. Okay? Anyways, so.
Can I start the test?
Yeah, that's all right. Sure.
Sorry.
Okay, you're gonna be right in the camera shot here in a second. So. Okay. Just type in your calculator, 3 decimal places, draw a rough sketch of what that should look like. Write this back to exponential form, write this to logarithm, don't solve these. Simplify that as far as you can. It should be a number. You should not need a calculator for that. Same with these. This one, do circle method and solve for x. It should be super simple. Expand this thing out. That's a cube root. I know it's kind of weird, but they put a 3 right there. Combine this down to one single logarithm. Solve by either doing a circle method or doing a logarithm on both sides, whatever it calls for. I think logarithms are easiest. Natural logarithm or log. These, combine these down and solve. There should be 2 answers, but one of them probably works. This, it's only one formula because you can do it on 2 different ones. Figure out which one's the better deal. Okay. They should be really close together. 16. You probably read this before. We've done this problem a couple times now. Just use that formula. Figure out the growth rate in the first, and then on the second part, use that growth rate. Same with this one. This one you can make up your own numbers. Like I used yesterday, like 150s and stuff. You can do that on this. Here's your formula. You're figuring out half-life first, figure out growth rate. And once you have that, then you can do another problem with this, but you're going to do 80%. Okay. This one, this is the formula you're going to use. You can figure 2006 and then figure out the growth. Okay. All right, where are you at? Are you down in? Okay, have her send me an email. Okay, have her send me an email when you get there. Okay, because I'll probably give her some instructions and whatnot. So that way she knows that you're not cheating if you're using a calculator and whatnot. All right. Okay. So first, real quick, the vocab terms that are involved here. Okay. For the review words, we have point. We have to talk about that word. We have to talk about lines. We had the different classifications of lines. So, in fact, what was that?
I thought we talked about point. Or was that something?
Yeah, I'm going to do a quick review. These are just kind of go over these one more time. I want to do a quick review of the classifications of lines. And then the last word that we talked about yesterday was the word plane, a geometric plane. I think we ended with that. There was this really kind of more challenging vocab word that we discussed. That's what we're going to look at today. And then the last part is we're going to get into some brand new stuff. The new stuff we're going to get into is angles. And that's what we're going to get into. Okay, and we're going to look at the different classifications and how to measure and all that good stuff today. Because this is a type of interaction. So that's what we're going to be looking at. We're going to look at the classifications and how to measure. So.
Wait, wasn't the one hard word that you were just talking about like a few seconds ago? Isn't that like called the interaction or something like that?
Yeah. So the angles are a type of interaction with objects. We'll look at that today, and then we'll discuss the first type of interaction that leads to this one, and then tomorrow we'll really focus on the last two. This stuff is going to require that I'm going to have you draw some stuff today. So I will give you a little piece of paper here, and we're going to draw some stuff on it. Okay? All right. Questions, comments about what we're doing today?
Nope.
All right, perfect. At the very end of the day, I will give you a exit ticket where you have to fill out some information and see if you kind of if you remember the vocabularies we talked about. You do need to take notes today, so definitely take notes. Okay? All right, so the first one, let's talk about the word point. Let's talk about that word. Okay, what do you remember about a point? What do you remember about the word point?
Not Darth Vader.
Okay, for two that were here yesterday, what do you guys remember about the word point? How do you draw it? What do we label it with?
A and B.
Yeah, you just put a dot, A and B, just use the letters of the alphabet, right?
Right.
That's a point. It represents its position in space, there's no size to it. It's not like when you look at a map and the cities that are bigger have bigger dots than others, this doesn't matter, okay? That's a point. Now, what we'll talk about today is the first type of interaction we have. The first type of interaction we have actually makes points, and that's what we're going to look at today. That's one of the first types, and that leads us to our new vocab word that we have today, which leads to all these classifications. So that's a point. Second thing we talked about was lines. There was 3 types, or classifications. I don't know how you want to say it. Okay, you guys remember one of them. There's 3 types. What is the first type of line called? What were the names? If you think of any of them, say it out.
Wasn't one of them parallel or something like
No,
that?
no, that's the type of interaction. That's coming up later. You're already ahead. You're already ahead
Okay.
of what we're going.
Thank you.
So,
I'm gonna come back to that one.
yeah, you'll come back to that. No. That's different. That's different than what we're talking about. Types of lines. First one was self-entitled. They just called it a line. Self-entitled. Okay, when you draw a line, this is what it looks like. Has 2 arrows.
Senor Eros.
Has 2 arrows, and it has points on it. It can have multiple points. It really doesn't matter. In fact, I'm going to put this this thing is going to have 4 different points on it. Let's call this B, C, D, and E. Okay, it has multiple points. Now, when you name it, when you name a line, you have to give me any of those 2. So, in fact, we'll just start with Eric. Eric, pick any 2 letters on this list, and you can put them in any order you want.
B,
And
C.
B, C. Okay, you're right like this. B, C, and you draw little arrows above it. This is how you name the object.
A, C, B, C.
Okay. Okay. If you want a DC, same thing. Or you could go DC. Fine. You pick any 2. You can put them in any order you want. But that's how you name it. Now notice what goes above the letters.
The Eros.
Arrows. If you forget the arrows on my next homework or the next test, I do count them wrong. You do have to have those in there. I'm very particular on how you write a line. Because the arrows means it goes on forever. There's no limit to that line. The definition of a line is a geometric figure that connects 2 points and continues in both directions without limits. So it keeps going forever. Okay, do we feel comfortable with the first one, the line? Second one we did yesterday. Now, is this starting to jar your memory? Do we start to remember some of these now?
I remember from last year.
What was the second type of line? You guys remember?
Oh, shoot.
One started with an R, one started with an L. The second one we have is 2 words. The 2 words are L and S.
Line segment.
Aha, line segment. Very nice. So line segment, very nice. That's impressive. All right. For a line segment, you have 2 dots and all the points in between. F, G, with 2 dots, and that's for a line segment. How you write it? You just write the 2 letters, and you put the little bar above it. FG, bar above it. Make sense? This is what I expect to see. Now you can switch the letters around, doesn't matter. But notice, does that have arrows on it?
Nope.
Nope, not at all. Okay. All right, and the last one, the last type of line, starts with an R. It's 3 letters long.
Oh.
The second letter is an A.
Ram.
3 letters long. Second letter's an A.
Oh, I can't pronounce it.
It's called array. Array. Okay, when you write array,
I was actually thinking of an expert.
okay, here's how you write array. You pick 2 points. Let's go with this H and I. And there's going to be an arrow going one direction. Now, I'll let you guys choose. Do you guys want the arrows going toward the H or the arrow going towards I?
I.
I? Okay, so I'll have the arrow going towards I. So this is what array would look like. That's array. Has 1 arrow. So what they said is it's a geometric figure that contains 1 endpoint, has 1 end, and it has an arrow that goes without limit in one direction. Okay? Now, when you write this is how you write it. You write the 2 letters, because again, we always use 2 letters, and you put the arrow going towards the letter that it passes through. You guys picked it went through I, so the arrow better be above I, because that's the one it passed through. The dot, the endpoint, you can put the arrow or the dot above H, because that's where the endpoint is. The most important letter there is H. It's where the endpoint is. Okay, are we good with those objects? Now, the big thing is they're all lines, right? They're all types of lines. What we had this vocab word that I used yesterday is that dots can be what they call quote-unquote collinear. This is a word that we used at the very end of class yesterday. Collinear, yep. It means that everything is in a straight line. Like you gentlemen are sitting in collinear with each other. You're in a straight line with each other. Okay? If you guys were to like move out of place, then you wouldn't be collinear nor you'd be called non-collinear. So it means to be in a line. Okay, does that make sense?
Yep.
Okay. So that's the key word. If you're not in a straight line, it's non-collinear.
Hold on, don't erase that. I gotta write that.
No, that's fine. I'm gonna leave that up there. Okay, now the last word that we discussed yesterday was the word plane. That was the last word we had yesterday. I'm gonna put the word plane on the board and we're gonna discuss it here. I'm gonna put it right here.
Like an airplane?
Nope, no airplane. We're talking about a geometric plane. A geometric plane is when you pick 3 points that are not in a straight line with each other. So what they call non-collinear points. So in fact, I'm going to put this in quotes. Non-collinear points.
Hey Sam, we only have 3 periods left.
Okay. And you have to pick 3 of them. Okay, so if you're talking about a plane, this is what I'm talking about. Pick any 3 dots. Let's call this X, Y, and Z. These are my 3 dots. Just pick those letters out of the alphabet. Then the idea is that if you have 3 or more, there is a plane that can touch them. A flat surface. Now, how you name a plane? How you name it? Like, because the other ones, they have very distinct names. You use the 3 letters that are on it. You put the 3 letters that are on it, and you put the word plane out front. Plane, X, Y, Z. Okay, that's how you do it. Notice no arrows.
0.
All right, here's what I'd like you to do.
Oh boy.
First drawing of the day. Let me give you some paper here.
Oh my.
Is it a sign for us to go home?
This will be a part of what you have to turn in the very end. Okay, all right. Put your name on. Date today is the 8th, so it's 5/8.
Yeesh.
Okay, put your name on it. You can use the blank side, you could use the side with the lines. Some people like the blank side.
I'm gonna put my
It's
name
easier
on
to
the
draw.
line side and then
Okay.
draw
Blind side.
All right. Okay, on your piece of paper there, I would like you to draw 4 points. 4 points. That's all I want. 4 points on the paper. Label them with any letters of the alphabet you like, but they have to be the main 26 letters. Okay? So you're going to draw 4 points on your paper.
Why not 5?
Just 4.
Dang
Right.
it.
That's an odd number, we need even numbers.
Okay, so.
We're just going to go 4 for it. Now,
Only if I could put
I
C
didn't
twice.
tell you where to put them. You could put your 4 points anywhere you want. It's up to you where you'd like to put them.
Only if I could put,
So
pick
pick 4 points, label them.
yeah, only if I could put C twice.
I know
Okay.
I like.
Okay, you got your 4 points?
Yep.
Okay. So far we've got 2, and we're looking for 4 total. Alright,
Shut up, boy.
4 points.
What happens if we do go over?
Go to 5? That'd be good. I'm just looking for 4 though.
You get an F.
No.
Okay, are we good?
You failed. Hold up a minute. Fool.
Alright, now, this is an honest question, because it was free for all for you guys. Raise your hand if they're all in a straight line with each other. Raise your hand.
What if they both go like this?
No, if they're all 4 in a straight line, collinear with each other, like this. Are they all 4 in a straight line?
No.
No, okay. So you guys are saying that they're all non-collinear. So like they're not all 4 in a straight line with each other. Okay, that's good. Now here's the thing. I'd like you to hold up your piece of paper at an angle to your body. So what I mean by an angle, you hold it up, you can tilt it any way you want in front of you. Okay? Okay, like that. Okay, you can pick any way you want. Okay? That piece of paper is the only flat surface that can touch all 4 of them. That's the weird concept to think about. It's the only plane that can hit all 4 or all 5 at the same time. Because if I were to come in with my piece of paper, and try to hit your 4 dots with one piece of paper, I could not put it on the paper and hit all 4 no matter how I tilt it. The only way I could do it is if I put it flat against your paper and now I touch all 4 of them. Does that make sense? So it's a weird situation. What you're actually experiencing is a plane. Now, if they're in a straight line, kind of like this is almost a straight line. Now, on this particular example, I can have any plane can touch all 4 of these. Because this piece of paper is a plane, it's a flat surface, right? You can imagine it continues.
Right.
But this plane could also hit all 4 like this.
Aha.
I could actually put it at a different angle and I would hit all 4. So that's not a unique plane, okay? I could tilt it at a different angle and hit all 4. I could tilt at another one. So there's an infinite number of planes because I could just keep spinning them and it would go through the paper and come out the back. Okay? So if you put them in not in a straight line, it makes the unique plane, which is the piece of paper in front of you. Alright, now here's what I'd like you to do. I would like you to connect any 2 dots together with a line.
Oh, gosh.
Just 2. Pick any 2 of the dots you like and connect a straight line. If you're already done, that's good.
That was easy.
Okay, you're going to connect it with a line.
Oh, shit.
Any two of the points you pick. Okay, now I asked for a line, correct?
Yeah.
What do lines have? Look at the top one, number 1. What does a line have to have when you draw it?
Arrow.
Arrows, you better have arrows on it. So make sure it's an arrow. Arrows on the outside. So, yeah, so if you pick 2, draw a line, you gotta make sure on number 1 there. Connor, you gotta make sure you have arrows, because I wanted a line. Lines have arrows. So you better keep going and draw arrows past it. Okay, good? Alright. Now, okay, you have your arrows. Now, here's what I'd like you to do. I would like you to flip it over now. Flip it over. Okay, flip your piece of paper over, so now you're on the other side, and you should be on the side with a bunch of lines on it, correct? The blue lines? Okay. Maybe you should have lines on one side at least, yeah. So I use no
side with the line.
Oh, okay, you're fine. You're fine. Okay. All right. On the other side, here's what I'd like you to do. On this side of your piece of paper, so on one side you have all of your drawings. So on this side you have all your drawings, whatever you had, and you had your line and you had your arrows, whatnot. On the other side of the piece of paper, so if you flip it over, I want you to name the plane. I want you to write the name of the plane you had on the other side of the piece of paper. Okay, if you want to know what the names are, I have an example up on here on mine. So this is the name of my plane, because that was the letters I used. Okay? And the second one, so that's the first question you have to answer. Name the plane that you had on the other side of the paper. Number 2, you have to name the line.
Isn't
Name
like Magic the Gathering,
the line.
planes blocking away?
So name the plane, name the line on the other sheet of paper. I have examples up here. This is the name of my plane. If this is my line up here, this is how I write my line. Or a BC with arrows above it. I want to see that you have both answers down. The plane answer comes first. I'm going to walk around, I'm going to check.
Wait, what was the second thing?
And you have to name a line. So you have to look on the other side and name the line that was on the other side of your paper.
Well, you already kind of named it for me.
Okay, just name it, put it down. Because it has to look like mine. Mine was that one in black. So on this side, you got to name the plane. So the plane that was over here, name the plane that you want. So plane, you have to use the name of the plane. You have to use the word plane and a couple letters. And then when you name the line, that's the second question. You have to use the 2 letters that are on your line and arrows above it. That's what I'm looking for. So plane. Okay, that's good. You don't need to slash to it. You don't have to use 3 letters. Okay? And now you have to name your line. So that's the thing I'm waiting for. So
You should
plane.
do 4 letters.
Plane.
I don't know 4. I'll cross out the slash at least, that's it.
He's getting confused on mine.
Yeah, I'm getting confused.
That's so, wait a minute.
What's that?
That's a name, buddy.
That's a name?
Yes.
Yeah, you just added in a letter
Yes, it is.
Alright. So here, I'm a little disappointed with the naming system here. I just went through it a little bit ago here. When you name a plane, this is what I want. You have to write the word plane. You have to use 3 letters that are on it. It's not that difficult. So if you didn't use 3, it's kind of wrong. So if you had 4 letters on it, because maybe it was W, X, Y, and Z, fine. You have to write the word plane, and then you have to write 3 letters down. I don't care what letters you have.
Good.
Okay? And they can be in any order you want. So that's a plane. That should be something like on your first answer. Didn't see a lot of that. Okay, maybe I saw one that did it correctly. Alright, second one. When you name a line, because on one of your things you did have a line that was connecting 2 of your letters, correct?
Oh, yeah.
When you had the line, you had the arrows. This is how you name it, naming the line. You have to write the 2 letters down, and then you have to put arrows above it. That's how you name it. I want to see that on paper. The 2 letters with arrows above it for the line. So you should have 2 answers on the one side of your paper.
There.
Let's see.
I do a short line.
Okay, you did your short line, and what was the name of your plane though?
M-A-D.
M-A-D. Okay. Alright.
Oh, shut up.
Boom, 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 boom. Alright, and the only thing you have to name now is your line. So I did an example of my line. I used 2 letters and put arrows above it. So, not the word line. You actually have to write the 2 letters with arrows above it. This is how you name the line.
Oh.
This is what I'm looking for right here. The parts I have in the boxes, that's the name. That's how you name it. Or like this. That was an example of my line right here. That's what I'm looking for. Not just a word line. It's not how you name it.
No fun about 4
Okay.
letters.
Alright, it's good. We got them all.
Boy.
Okay, good. We got the letters. Alright. Okay. Line. On a line, you only use 2 letters, not 3.
Okay, I'm giving up now.
So. Okay. Alright. Now.
Buddy.
Okay. Do we have examples of those? Okay. I'm going to come around and collect those here in a minute, make sure your name's on it. Okay? Second drawing we're going to do here in a minute. We're going to talk about the different interactions. And that's going to get us to this first one, which are all the types of angles today.
Now it's just AC. Like the AC you turn on in your house.
Alright, here we go.
Haha.
Oh, wait. AC?
Alright. So, the different types of interactions. This is what I like you to write down in your notes somewhere. Not on that piece of paper, but somewhere in your notes. The different types of interactions. There's 3 or 4 major types. The first one is the most common, okay? This one we're going to spend probably the most time on. Okay, number one is if things are intersecting. Intersecting or intersection. Same word, okay? All right, so what this means, it's when two geometric figures share common points.
So where the lines pass through each other.
Yeah, two geometric figures share common points. Okay, that's the definition that the book says. Okay, I think the best way that Sam you just described it is when the two lines cross. Okay, boom, it was like this. We had one line, we had another line crossing from yesterday. This is the intersection. It's like when two roads cross. Okay? Now, here's the thing. We also had different types of geometric figures that also intersected. Think back to like English class. A lot of you guys do a Venn diagram. Like that. A Venn diagram where things overlap. An intersection is the points where they actually collide. It's the actual dots where they collide. A Venn diagram is used for visuals so that people throw things in the middle of the circles. But what I'm looking for is the actual locations where they cross. That's an intersection. Does that make sense? Okay, second one. And I think you even said it earlier, Sam. I was asking for the name or the types of lines, and you said a word earlier that you said you were going to try to remember when you came back to it. Do you remember what that word
I was
is?
gonna remember it.
Started with a P.
The parallel.
Parallel. Nice. Good memory. All right. So parallel. Okay. Parallel lines do not cross. So on this little piece of paper here, you have the blue lines. The blue lines are non-intersecting. Okay. The definition of parallel: geometric figures that do not intersect. Do not intersect. Now, the big thing about this, knowing that they do not cross, right? They don't meet. They're also equally spaced. They're equally spaced, and they're on the same plane. So what I mean by that is if you were to draw two lines on your piece of paper that don't cross each other, you're on the same plane. You're going to make them equally spaced like this. Okay, those would represent parallel lines, like a railroad track. Now, here's my question. Are lines actually parallel? Can you actually have two lines that never meet? Think about it. Yes. Okay. Equally spaced. Okay? So, here's what I like to do.
Wait.
I don't know if you can experience this in this room.
What?
Okay? I don't think we have enough, we don't have enough line of sight here. Okay, we're going to step out in the hall just so you can see this. All right, come here. Let's go out to the hall. Here we go. We're going to experience actual parallel lines. Frame. Okay, so what I'm going to do is I'm going to show you a picture of lines that are in theory parallel to each other. So you guys get to experience this. All right, so let's pull this up. Okay, we're going to go to Google Earth. So if you've ever experienced Google Earth before, it's kind of a cool program they have on every Mac.
Google Earth.
Okay, it's awesome. All right, so here's Google Earth. I'm going to type in Garner, Iowa. Okay, and we're going to take a look at a certain road that's in Garner. Okay?
Actually,
Are you
it goes
sure you
straight
typed it
to, you can look at the moon, you know.
Yeah, you can look at other planets. It's pretty cool.
Dude, I wanna do that. Let's go look at
Okay,
Mars.
Garner.
Get my candy bar.
Oop,
That's so old.
that's I want Garner, Iowa.
I'm so
Alright.
glad I can use it.
American Ninja Warrior, Ninja versus Ninja.
Okay, so here's Garner, Iowa. This is kind of where we're at. We're over here by the high school, over here. This is where we're at currently. Okay.
Go click on it.
Yeah,
Like,
we're not going to go
Street
that way.
View.
All right, what we're going to do is we're going to look at Highway 18. This is over by the golf course, okay? So when you look at Highway 18, this is a perfect view of it. Hopefully you can see that. You can see the white lines on the road. Okay, the white lines on the road are equally spaced. They are parallel, right? Otherwise you'd have cars crashing all day. So they're equally spaced, right? There's so many, I don't even know the number. I don't know if it's like 18 feet. There's a certain number that they have to be apart. Now, I know 18 for us, there's like 3 lanes. but in certain roads there's 2, and that's the shorter distance. Now, what I want you to experience is seeing the road not from top like eagle view, but looking at it at a weird angle like what we were doing out in the hallway. So, this is the kind of the cool part that Google Earth can do.
Yeah,
That it can go to,
You can go onto the Earth.
yeah, third person view. And what you're experiencing here is you're actually seeing the white lines. And where they're actually meeting is they're meeting at this point on the horizon where the cars are going. The lines are actually meeting at the point of infinity down the road. So it's this debate that they have in math, and the debate is called Euclidean Geometry versus Non Euclidean, where there's these radical group of people that believe that parallel lines do not exist. And then there's a certain group of people that believe that they do exist in certain cases. I have to be in both parties because I want to teach both, right? So the experience is like, most people say, well, it's how you look at the picture, right? Because the eagle view, you can see they're equally spaced. From this weird perspective, you're not on the same flat surface, you're looking at it from a weird angle, it kind of is deceptive. And that's kind of the idea. So, and that's the argument that they have, okay? That there's no actual curved lines, or there's no actual straight lines. Everything is curved eventually, and they'll always meet because we're on the Earth itself. So I thought that was kind of a cool view. That's called street view, so you can do that in Google. Kind of
you going railroad?
So yeah, so kind of a cool perspective. It was just one of those things you just have to experience it. You have to see it for the first time. All right. So that was this first type of interaction. You could have figures like actually touch each other. Okay. All right. All right. So let's take a look at the other types of interactions. So we have things that are parallel that they don't meet. We have things that do meet. And the other option is what if they're right on top of each other? But so you can't actually tell the difference between them. They don't look parallel, but they don't look like they're intersecting either. They're just like, you couldn't even tell the difference. That type of interaction is called to coincide. So number 3, because I said there's 4 of them. It's to coincide. It's when 2 objects share all points.
Got it.
2 geometric figures share all points. So here's my example. This is the easiest way I can explain to somebody. So if somebody were to come up and do this, here's my line, okay? And somebody else were to come up and take their marker and trace it. Go right on top of it. Now, unfortunately, you guys can probably see the difference. You can see the other one below it. But if you didn't have different colors, I would not tell the difference. The lines are right on top of each other. Every point on the line is actually shared. It doesn't matter if they're those 2. There's an infinite number of points that are actually shared there. It's called coinciding. It's actually the same object. There's no difference. Okay, so that's to coincide. The last type of interaction today, the last type, is by far the most challenging to understand.
After the bell rings, Tyler Nielsen, Colton Steinhardt, Caitlin McCord, Carly Hanna, please come to the office.
The last type of interaction is actually when there's a lack of interaction, kind of like parallel. It's called skew. It's 2 geometric figures that do not intersect, but they're not parallel either. They do not intersect. They will not touch, but they're not parallel either. And I want you to think about that. 2 figures that don't touch, but they're not parallel like railroad tracks. So think about this. Because most people, they try to draw lines. This is what they draw. Okay, this is parallel, right? They're not going to touch. But I want to show you an example of skew. Instead of railroad tracks, this is skew. Look at this. That's skew. They're going different routes, and they're not touching. Okay? Okay. So one is going right, one's going right and left, the other one's going up and down. Okay? All right. That's it for today. Those are the types. We didn't get to the angles. We'll probably start that tomorrow. You need textbooks tomorrow with book covers. You need your Chromebook tomorrow. Make sure you have them out. I need those little piece of paper with your names on it. You're gonna get points for that today. That's your exit ticket today.
Wait, Allison says it's pretty.
So, get the names on them. Perfect, perfect.
Hi, buddy.
Done. Perfect.
You, not